Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. And in this video, we're going to be talking about some arithmetic sequences. And so maybe kind of what does that mean? Well, when you're thinking of a sequence of numbers, you can say a sequence of numbers that has a common difference between every two consecutive terms. And I'll kind of go back through and define each of those, but I wanted to at least give you a picture, an idea of what those look like, so you can have that ordered list, or you can have a table of values like we've been working with. You can also have those points on the graph. So now maybe some review. What do you think the word arithmetic means? So if you are just thinking of addition, you can easily remember that that A starts with both of those words. So you can think, okay, arithmetic just means addition. And also, we can say more specifically, a sequence is an ordered list of values with a pattern. So for example, you could have the sequence 1, 2, 3, 5, 8, and 13. And so we would say that first value is going to be that first term, the second value is going to be second term, the third value is going to be the third term, and so on and so forth. For example, 8 would be our sixth term in our sequence. And so we're able to also see that, hey, what do those three dots at the end mean? Well, that's called an ellipsis, and that just means that it keeps going, kind of like a conversation. On iOS, you're anticipating a response back, and so that just means there's going to be terms after 13. And so then a definition for a term, we can say a term is each value in the ordered list, and then we say the nth term is the term that is in the nth space in the ordered sequence. So let's kind of break this down. What does that mean? Well, when we're saying the nth value or the nth space, it's just saying, okay, we're choosing that value of n. And so we're saying sequences can be described using the u sub n notation. Again, it's pronounced u sub n. And you want to make sure you're thinking of, a exponent is called a superscript because it's above the normal line of text, where the subscript is below. So that's why we say the u sub n. And so then an arithmetic sequence is just a sequence where the difference between two consecutive terms is constant, or just through each of those terms it's the same. So we're saying this means that we are adding the same value each time. And you can pronounce it like this. You would say arithmetic. And so when we're talking about what does this word mean for difference, well, it just means if you have two ordered values, then it is the second value minus the first value. And you have to be careful with this because a lot of people just kind of subtract or add and do whatever they want, but you want to make sure you're following those correct directions. Also too, I want to define what the word consecutive means. Again, that means back to back or one after the other. You can say an example would be consecutive days of the week. So 2 consecutive days of the week would be Monday and Tuesday, or Friday, Saturday. And then also too, as a reminder, the word constant just means the same. So when we're thinking of a constant rate of change, it's going to be the same value each time. And so an example of an arithmetic sequence would be like this. It would say 8, 11, 14, 17, 20, so on and so forth. And so we're looking, okay, what are going to be the common difference between those values? Well, we're saying, okay, hey, between 11 minus 8 is going to be 3. So you have to go 3 steps from 8 to get to 11. And that's true for each of these values. And what I can do is I can say, well, this pattern is consistent. It is a constant rate. And so I can say, what is going to be my next term? Well, it should be 23, and we can find maybe the 21st term, but there has to be a simpler way. Instead of just sitting here and writing out the entire sequence, we might have very large numbers. So there absolutely is a simpler way. And so this is going to be our key idea for this video, is this arithmetic sequence formula. And it reads like this. It says u sub n is equal to u sub 1 plus the quantity n minus 1 times D. And you're probably thinking, okay, those are all different colors. There's a lot going on, and I don't know what those mean. So let's kind of define what each of those stand for. So we're going to say U sub n is going to be the nth term in our sequence. We say that U sub 1 is obviously going to be the first term. We're saying, if n is 1, that means that U sub 1 is the first term. N stands for the number of the term. Again, we choose this normally. And D is going to be that common difference. That's that constant value that is changing from term to term. And so we're going to use this formula to be able to find any term in our sequence. And so, for example, in the first one, it reads like this. It says an arithmetic sequence has first term 7 and a common difference of -3. Find a general formula of U sub n, simplify your answer, and then find the fifth term. So we've got a couple objectives, super simple. So what I want to do first is this. I want to say, hey, I have the two key parts that I need to be able to start using that formula. So I have my first term, which is U sub 1 equals 7, and then I say my common difference D is equal to -3. And so I'm able to do this in 3 simple steps. First, I want to write down that arithmetic sequence formula. So I have U sub n is equal to U sub 1 plus the quantity n minus 1 times D. Then I want to make sure I can substitute. What I'm substituting is this. I'm saying I'm taking my values and placing them in for my variables. More specifically, we have our U sub 1 and our common difference. And so I'm going to plug in those values for those variables. And so now I have this equation. I have U sub n is equal to 7 plus the quantity n minus 1 times a -3. And so what's that last step going to be? Well, it's going to just be simplify. So what we're trying to do is we're trying to take this complicated equation and have a nice, clean, simple answer. And so the way to do that is we're going to work on one side, because that's where those order operations come into play. And so what I need to do though is I notice, hey, I want to multiply, but I have terms inside those parentheses. So I have to use that distributive property. Again, that just means to multiply the terms inside the parentheses by the term on the outside. And so what I'm going to do is I'm going to take a -3 on the outside, and I'm going to multiply it by the terms inside the parentheses. So I have a positive 1n and a -1. So I need to multiply -3 to each of those terms. So I first look at that first term. So I have -3 times a positive 1n. Again, we will write the products inside. So be mindful of those positive and negative symbols. So that product is going to be a -3n. And I move to the next term and I say, okay, -3 times a -1 is going to be a positive 3. And so now I have this simplified expression. I have 7 minus 3n plus 3. So we're saying, okay, we moved from this blue line to the yellow line, and all we did was the distributive property. So now what we can do is combine our like terms. Again, you want to group those apples, group those oranges separately, so that way you can have that same idea. Again, these are constants, meaning they're just simple values, so I cannot combine them with variable terms like -3n. So I did 3 plus 7 equals 10, and now what did I have? I said I found my simplified sequence, which is exactly what it's looking for. It's looking for that general formula. So are we done? Never, but we want to say we want to find that fifth term. So how do we do that? Well, this is just like our linear function. So what we're going to do is I'm going to plug in the value for the variable and simplify. So wherever I have an n, I'm now going to have a 5. And so I take that 5 and I plug it into this general formula that I found. And so my rewritten equation, I'm saying, okay, fifth term, U sub 5 is equal to, and I have -3 times 5 plus 10. Now I can use those order operations again. I'm going to multiply those two values together to get -15. The positive 10 comes down, and so I have -5. I circled my answer, and I think I'm done, but really, what did I just find? I want to always make sure as I'm getting through, towards the end of our problem, what did I find? Well, we found that -5 is the fifth term in our sequence. And so we're saying, okay, here's the general formula. We wanted the fifth term. We found that the fifth term is -5. In the second example, it reads, an arithmetic sequence has first term 3 and a common difference of 6. Find a general formula for use of n, simplify your answer, and then find that 13th term. So just like before, we're going to say, hey, what's my first term? Use of 1 equals 3. And what's my common difference? Which is d equals 6. And so now I take those, I have my formula, need to substitute in my values for my variables. I simplify, so I distributed the 6 times n and the 6 times the -1. And so now I have this equation, u sub n is equal to 3 plus 6n minus 6. And so if you got lost between the substitute and simplify, make sure you're seeing it, I distributed that 6 to each of the terms inside of the parentheses. And so now I can combine like terms, and my simplified general formula is going to be 6n minus 3. Okay, now next step, we need to find that 13th term. And so we just let n equal 13. Again, this is just like those wonderful linear functions that we had. And so I'm going to plug in wherever I have an n, I now have a 13. And so I have 6 times 13 is a minus 3. And so be careful again, you can't just throw that 13 right next to it. You have to have it in parentheses because we are multiplying. So I have 6 times 13 is 78, and I have 78 minus 3 is going to be 75. What did we find? As always, we found that the 13th term in our sequence is going to be 75. Feel free to ask any questions, rewind, replay, all that good stuff, and as always, super slam that subscribe button.